this video, let us see the derivation of the equations for chords, tangents, normals to an ellipse. Here there is an ellipse with the center at the origin, and its equation is x square by a square plus y square by b square is equal to 1. Let a and b are 2 points on the ellipse. The coordinates of a is x1 y1, coordinates of b x2 y2. So this is the chord joining a and b. x1 y1 is a point on the ellipse, so that point, this coordinate should satisfy this equation. So you can write x1 by a square plus y1 by b square is equal to 1. Similarly, b is also a point on the ellipse, so its coordinate should satisfy this equation. x2 square by a square plus y2 square by b square is equal to 1. So here right hand sides are same, so you can equate the left hand sides. So equate these two. x1 by a square plus y1 by b square is equal to x2 square by a square plus y2 square by b square. Now we have to get the slope of this. To get the equation of this line, we should know the slope. So now you rearrange this, take this to this side. So y1 by b square, this when it is taken to this side, minus y2 by b square. So b square common, so it's written down. Then this you take to the other side, so x2 square by a square. Then when this is taken to the other side, minus x1 square by a square common, it's written down. Now y1 square minus y2 square, it can be written as y1 plus y2 into y1 minus y2 by b square. Similarly here, x2 square minus x1 square can be written as x2 plus x1 into x2 minus x1 by a square. Now for getting the slope, we should know change in y coordinate by change in x coordinate. So we want here y1 minus y2, here we have to make it x1 minus x2. So this can be written as x1 plus x2. This x2 minus x1, you write it as x1 minus x2 by a square. Then it is, we change this x2 minus x1 written as x1 minus x2, so there will be a negative sign. Now y1 minus y2, this x1 minus x2 is equal to, take this b square the other side, so minus b square by a square, then x1 plus x2 divided by y1 plus y2. So this is the slope of this line. The slope of the chord is. Now we know the slope and 2 points. So if you know slope and 1 point, we can write the equation of this equation of a line. Now we can write the equation of the chord. So this is the equation of a line with point slope form. Now we know the slope of this chord. Then point, the chord is passing through the point x1 comma y1. So y minus y1 is equal to, for this slope we can write this minus b square by a square into x1 plus x2 by y1 plus y2, the slope, then x minus x1. So this is the equation of the chord. Passing through x1 comma y1 and x2 comma y2. Now this chord will become tangent if x2 y2 coincides with x1 y1. It will become the tangent at x1 comma y1. So this point is going on moving, and finally here at that time x2 will become x1. So in this expression, wherever x2 is there, you write x1. This x2 you write x1. Now for the y2 you write y1. When these points coincide, chord will become tangent. So in this expression, where there is x2 you write x1, where there is y2 you write y1. Now you can x1 plus x1, that is 2x1, y1 plus y1, 2y1. So now this 2 will get cancelled. Then after that you rearrange y minus y1. Take this y1 to the other side, so it will come to the numerator. y1 this, then y minus y1 by b square. Now this b square you take to the denominator this side. Then this minus x1, x minus x1 by a square. Now this minus xx1 by a square you take to this side, so it will become xx1 by a square. Then here y1 by b square. Now minus y1 into y1 square by b square, minus y1 square by b square you take to the other side, so it will become plus y1 square by b square. Now minus into minus plus, so x1 square by a square. Now x1 comma y1, this point is on the ellipse, so it should satisfy this equation. X1 square by a square plus y1 square by b square should be 1. So for this we can write 1. So this is the equation of the tangent at the point x1 comma y1. So easily you can remember this equation of the ellipse is x square by a square plus y square by b square is equal to 1. To get the tangent at the point x1 comma y1, where there is x square, you can write xx1 by a square plus y1 by b square is equal to 1. This is the equation of the tangent. So this is the equation of the tangent at the point x1 comma y1. So this is the equation of tangent. Then now we have to get the equation of the normal. It's a chord. This is a normal. For that we will rearrange this. Now a square b square. So a square b square is LCM. Then when this is divided by a square, then this b square xx1 plus when this is divided by b square, then a square, then this a square y1 is equal to 1. Take to the other side, so it is 1 into a square b square. Now take this to this side, so you'll get the equation of the tangent in another form. So ax plus by plus c is equal to, so equation of a line is ax plus by plus c is equal to 0. Now perpendicularity of two lines, we can apply the condition for the perpendicularity. If two lines are perpendicular, product of their slope m1 into m2 should be minus 1. So you interchange the coefficients of x and y. Here coefficient of y is a square y1, that you put it for x, and coefficient of x is b square x1, then change the sign of any one, this plus, then this constant will be different. I have written the constant the other side. So condition for two lines to be perpendicular, so product of their slope should be minus 1. Then the normal passes through the point x1 comma y1. So for this x we can write x1, for this y we can write y1. So we are getting the value for this k. Now for this k we can substitute this. So now here see x1 y1, so you can take it outside. So value of k is x1 y1, then a square minus b square. For this k you can substitute this. Now y1 a square x minus x1 b square y is equal to k. For this k you can substitute this x1 y1 into a square minus b square. Now a square minus b square you keep it in that side, then x1 y1 you take to the other side, so it will come to the denominator x1 y1, this x1 y1. Now y1 will get cancelled, so a square x divided by x1 minus here x1 will get cancelled. So b square y divided by y1 is equal to a square minus b square. So this is the equation of the normal at the point x1 comma y1. So now you know the equation of the tangent in the Cartesian form. This is the equation of the normal in Cartesian form. Now let us see parametric form. So you know the equation of a ellipse in the parametric form. X is equal to a cos theta, y is equal to b sin theta. That is the equation of a ellipse in the parametric form. Now instead of x1, now we can write a cos theta, and instead of y1 we can write b sin theta in this expression. So instead of x1 you can write a cos theta, because x1 y1 is a point on the ellipse. So instead of x1 you can write a cos theta. Instead of y1 we can write b sin theta. Now a square is there, so it will get cancelled and it will become a. So x cos theta by a plus y sin theta by b is equal to 1. Here b square, so after getting cancelled it's b. So this is the equation of the tangent in the parametric form. That means if you remember the equation of the tangent in the Cartesian form, you can get it using this relation. Now this is the equation of the normal in Cartesian form. Cartesian form. For getting the parametric form, for this x1 you can substitute a cos theta. For this y1 we can substitute b sin theta. So a square a, after cancellation, ax by cos theta minus by by sin theta, b square b, so b, then a square minus b square. So here you can see x cos theta by a, but here you can see a x by cos theta. Instead of plus, minus. Then here y sin theta by b, but here by by sin theta. So this is the equation of the normal in parametric form. Thank you for watching.